Hello, this is Siamak Farshidi, a PhD candidate from Utrecht University. Recently, we have designed and implemented a decision support system for assisting software architects with their design decisions in pattern-driven software design. Let's log into the system and see how it works. Okay. As you can see, we can make a new decision based on these 6 decision models that we have, including software architecture, pattern selection, and also we can open one of the decisions that we have already made. Let's open one of the recent decisions. Well, firstly, we need to describe the decision-making problem in terms of the title of the problem, short description of the problem. Also, we can upload a logo for our decision-making problem. Next, a software architect needs to define her feature requirements. For instance, she can indicate that graphic user interface as a must-have feature, or handling user input as a should-have feature, or even she can mention that support access control is a should-have for her, or she can actually indicate her quality concerns such as time behavior, reusability, security, or performance efficiency as different quality concerns, and assign one of the must-go priorities to these quality concerns or feature requirements to define her requirements. And then she needs to click on evaluate alternatives to see which of the patterns in the knowledge base of the DSS support those requirements. Okay. As you can see here, the DSS generated a set of alternative solutions for this decision-making problem, as it didn't find any single pattern that can support all the requirements of the software architect. For instance, a layer as one of the patterns, it doesn't support all these must-have features, and of course it doesn't support, for instance, handling user input as should-have feature. So the DSS actually generated this set of alternative solutions, and also it indicated the impact of patterns on the quality attributes of ISO standard 25010, and also it calculated the scores of those alternative solutions or combinations of patterns. I'm going to talk about these abbreviations in a bit. And also the DSS generated this decision structure for this actually decision-making problem, or office profit in this case, based on the feature requirements that the architect actually defined earlier. Okay, we can click on report to see a report on the results. First, we can see the feature requirements based on Musco prioritization technique, the impact of patterns on the quality attributes of ISO standard, top 10 feasible solutions, explanation of those solutions. For instance, the first solution was a combination of client server, share repository, cloud-based, layer, and C2. Also, we can see the impact of the patterns on the quality attributes. H means high, M means medium, and L means low. Question mark means that we didn't find any evidence to support the impact of the patterns on the quality attributes based on the systematic literature review that we have conducted.